Okay, we have derived the normal form, right? The normal form was our cos alpha into x plus sin alpha into y equals to t, where this alpha was the inclination of normal from origin to the line and t is the distance or length of normal from origin, right? Now, if any case or any problem, the standard equation of the line is given, right? And we want to find the length of normal from origin or its inclination, that is inclination normal we want to find. We will convert the given standard equation of line in this normal form, and as if I get the normal form, I can easily get the normal's inclination and its length, right? So how to convert a standard equation into a normal form? Just remember, divide the standard equation by root of a square plus b square. Divide by root of a square plus b square, right? On both side to the standard equation. What I will get? A upon root of a square plus b square plus b upon root of a square plus b square y plus c upon root of a square plus b square equals to 0. Here I can put this a upon root of a square plus b square as cos alpha, and this b upon root of, that is the quotient of y, I can put it as sin alpha. I'll take this to the right hand side, right? So if I take it to the right hand side, this will become negative. I'll make it to the left hand side, it will be negative, right? If I first shift the c to the right hand side and then I'll divide, so it will look like this, and this will be my t. If I compare this with my normal form, right? So how it is possible? I can't randomly put any value to cos alpha and sin alpha, that is the quotient of x. I am here putting cos alpha, quotient of y I am putting sin alpha, and the constant remaining on the right hand side I am directly taking it as a p, right? I can't afford to do like this unless these values are satisfying some condition, right? So always whenever you are putting some values to as cos theta or sin theta, in our case we are taking here alpha, any angle you can take, it should satisfy sin square plus cos square equals to 1 identity, right? Then there will be an angle present whose cos will be this value and whose sin will be this value. So we should first know there is an angle present whose cos alpha is this value and whose sin alpha is this value, right? So how to check? Just check this identity. Put these values into left hand side, and if its calculus square and sum is equals to 1, then I can put this substitution, right? So let's check whether their square sum is equals to 1 or not. Here if I square this, what I will get? I'll write here square of sin square, that is b square upon root of b square upon root of a square plus b square bracket square plus cos square. Cos square value is this, square it root of a square upon a square plus b square bracket square, right? After squaring I am adding, right? Here the base will be same. So what I will get in numerator? A square plus b square, and denominator is same, that is a square plus b square. This square root will be cancelled by taking the square, right? This a square plus b square, a square plus b square will get cancelled and I will get 1. That means these values square sum is giving me 1, and I can put them as cos alpha and sin alpha. This is proved. So every time while putting the values, you should first check this, right? Every time. If it is not following the identity, you can't put cos alpha and sin alpha to any values, right? or in straight lines, generally we are putting for the quotient of x and y. Right? So just remember this. Here this is following. That's why I can put it. Right? So I'll erase this. I hope all of you understood this. Why I am able to put this. So there should not be any doubt about this. Okay. So here, if I put this, what will be the value of my cos alpha? What is my value of my cos alpha is a upon root of a square plus b square. What is the value of sin alpha? B upon root of a square plus b square. What is the length of my normal? C upon root of a square plus b square. As the length cannot be in negative, that's why we are always taking it positive, right? Always remember this. So whenever there is any question of straight line and the standard equation is there, you want to convert it into the normal form, just divide it by root of a square plus b square, right? And directly take cos alpha sin alpha, because here we have proved it will satisfy, right? So to understand this, let's take an example. Let's take an example. This example is the second example. Reduce this equation. It is the standard equation, right? Standard equation of the line into normal form and find the value of p and alpha. That is the inclination of normal and length of normal we have to find. But before that, we have to convert this equation into normal form. What I just said, just find your value of ABC, compare it with your standard equation. What is the value of A? It will be root 3. What is the value of B? It is minus 1. Right? And what is the value of C? It is minus 2. Right? Now, just divide the equation by root of a square plus b square. First find root of a square plus b square, which is root of, what is the value of A? Root 3 square. Right? What is the value of B? Minus 1 square. What I will get? Root of 3 plus 1. That is root of 4. Root of 4 is 2. That means the value of root of a square plus b square is 2. I have to divide the standard equation by 2 to convert it into a normal form. So, what I will do, just divide the given equation, divide this equation by, what I will get? Root 3 by 2x minus y by 2 minus 2 by 2 equals to 0. So, what I will get? Root 3 by 2x minus 1 by 2y. I can write this as, right. This will be my minus 1 and I will transfer this minus 1 to the right hand side. Right. Here, this will be the value of my cos alpha that we have already seen. What is the value of sin alpha? Minus 1 by 2. What is the length of my normal is 1. Right. Here, easily I will get the length of normal, which is b. But here, I have to find the angle. This is my conversion into normal form. Just I have to put these values and first find the value of alpha and then put it. Right. So first note it down. Try to solve this. How I am converting the standard equation into the normal form. Right. I'll erase this. We'll solve it further. Here the value of cos alpha and sin alpha we know, right? So first find the value of alpha. How to find the value of alpha? Take the ratio, that is sin alpha upon cos alpha, which is minus 1 by 2 upon root of root 3 by 2. This 2 to cancel. What I will get? Minus 1 by root 3. Sin alpha upon cos alpha is tan alpha. And alpha is tan inverse of minus 1 by root 3. That means two values of alpha will be possible. How to solve this? You should first go through the basic inverse trigonometry and trigonometry to solve this. I will just revise. The value of tan for 1 by root 3 angle will be tan inverse of 1 by root 3. The angle will be 30 degree, right? But it is negative. tan is negative in which quadrant? In second quadrant and fourth quadrant, right? So angle could be pi minus this 30 degree. Convert this 30 degree into radian measure, because always we are referring in radian measure, right? We are not much dealing in this degree measure, right? Okay. So the angle can be pi minus second quadrant angle is pi minus pi by 6, or the fourth quadrant angle, that is 2 pi minus pi by 6. So the angle could be 5 pi by 6 or 12 minus 1, 11 pi by 6. So here two possibilities of alpha are there. One is this 5 pi by 6 and second is 11 pi by 6. Now I am confused here. Which will be my answer? So to find the exact value of alpha, just check in which quadrant my cos of alpha is positive and sin of alpha is negative. It is in fourth quadrant, right? Value of cos is positive, and sin is negative in fourth quadrant. That means I have to take alpha as negative in alpha of fourth quadrant, and the alpha is of fourth quadrant value is 11 pi by 6. So here I got the value of alpha as 11 pi by 6. Just remember this, okay? Now I got the value of alpha and the value of p. Here the value of p and alpha is known. Now we can easily write the given equation in normal form. I'll erase this. Just remember alpha is 11 pi by 6. Okay. So as alpha is 11 pi by 6 and the value of p is equals to 1, the given equation in normal form will be of cos 11 pi by 6 into x plus sin 11 pi by 6 into y equals to 1. This will be my normal form of the given equation of line. This is a standard equation. Its normal form will be this, right? So remember this, how to convert a standard equation to a normal form to find the inclination of perpendicular, that is normal from origin, and its length, right?